name is Marta Wisniewska, and I'm super excited to be a part of this conference, ngVikings, and welcome to my talk. I will tell you how to supercharge the speed of progressive web apps. I will tell you about PWA again, but this time I will focus on the performance. And even if you're not familiar with progressive web apps, but you want to improve the web performance, the presentation will be helpful for you as well. So now let me introduce myself. So my name is Marta Wisniewska, I'm from Poland, I live in Warsaw, and I'm Google developer expert in Angular and web technologies. I work as a front-end developer at Network Energy Services, and I love open source. I co-create this open source project called PWAA. If you're interested about PWA, you want to get some knowledge, visit this page and visit our profile on Twitter. And I love all things about technology. I love also coffee, sport, and community. If you want to keep in touch, if you have any questions regarding this presentation, you can find me on Twitter. I prepared this topic because I can see that there's still a lot of different approaches to PWA, different opinions, and for example, a lot of misunderstanding how to qualify up to progressive web app. Sometimes people think that if they can add icon to home screen, this is for sure PWA, but it means that there is added web manifest. It doesn't mean that it's for sure PWA, because if you can't check that there is applied service worker, you can't say this is progressive web app. And there's also a lot of talking about benefits from business side and from user experience side, like for example, benefits of better conversion rate or better engagement. But I was considering how it can be useful from a developer perspective. So I found the most universal and the most useful the performance. So it allows you to create faster web apps. And today I will explain you what exactly it means. So how does it make your progressive apps faster? Because it doesn't mean that it will improve all your performance metrics. I will show you what are techniques and architecture patterns to improve this web performance. So let's switch to the agenda. And I will start with caching. I will tell you what are caching strategies and design patterns to boost the performance of your app. Next, I will switch to the combination of progressive web apps with WebAssembly. It's quite interesting. Next, I will show you the most common issues based on performance tests that I did on existing progressive web apps. And last but not least, I will show you how to keep a progressive style. So how to take care about your CSS code, how to improve it to get better performance. At the beginning, I will tell you about caching. So I will present you caching strategies and design patterns. So caching is the main source of making progressive web faster. I mean faster than regular web apps. And if you use Service Worker and Cache API, you're able to cache network requests. And this cache is quite different than browser cache that relies on cache control header values. And the main difference is that better control over how cached assets are managed. Service Worker provides a persistent medium to keep network requests in a controllable cache. These requests can be scripts, other pages, images, or assets. And this is just a proxy between client and server. And from a practical perspective, this is a JavaScript file that is time on repeat visit. But even if the service worker is active and you have pre-cached all pages responses locally, it doesn't guarantee the page renders fast. It only means that the network requests are returned from the local cache. We can talk about web performance from different perspectives. And web app speed is more a factor of render time once the network responses are collected. And if your app is heavy, like have lots of JavaScript, big assets, your page takes longer to render and even service worker won't help you to improve it. And it's really important to remember that we should remove unnecessary JavaScript, CSS, libraries, and dependencies before caching. And we should run audit tests before caching. It's so important. And another tip is to optimize sizes of your images and all assets. Today I want to present you design patterns for caching that allows you to get faster web apps. But before I start doing this, we should consider two aspects. The first one is how do you render the app? We have two options. The first one is server-side rendering, and the second is client-side rendering. We have different caching for these options. And for server render app, we cache the static parts, I mean CSS files, JavaScript frameworks, and some images. But for client render apps, single page apps, we have a code that always lives on the client, so we cache that. But we also depend on dynamic data. So we need to add some code to handle that. We need to handle some data from database. And the general idea is that things with URL go in the cache and non-URL data goes in the database. Next question we should answer is, where does the data live? So you can retrieve your data from cache or from network. And based on this fact, we have caching strategies. So we should consider how to retrieve files to render your app, from cache or from network. And basic option common for regular web apps is just we only use network, so we only use requests and responses from server to render the whole app. Another option is cache all your app, so then you're sure that it will work even if you're offline, but it's not guaranteeing the fresh of your data. You need to manage versioning. From practical perspective, we can use combinations of the cache and the network to improve our app. And for example, we can check if we have access to the cache. If you can get files from cache, we use it. If not, we try to get it from network. And the opposite side, so we try to get network resources from network, and if it failed, then we try to get it from cache. Another option is cache network race. So in the same time, we try to get data from cache and from the network, and then we use the one delivered faster. And also, before we start caching, we should know that our app consists of two parts. The first one, this is the app shell, and the second is content. So the app shell, this is the static part of your app that are parts common to all pages, and the content is dynamic. So dynamic content populates the view, but shell can be cached and load instantly on repeat visits. Now it's time to talk which pattern solution is the best. So the best option is a combination of server-side and client-side rendering. For app shell, we use server-side rendering, so your server can draw the first page quickly. And for the client side, we use client-side rendering to serve dynamic data where JavaScript takes over and renders future pages. The next best option is a pure app shell, the single page app approach. So we use server-side rendering for application shell, and we use JavaScript to fetch content once the app shell is loaded. So we should cache the app shell, and we can speed this up using HTTP streams to begin rendering content as it comes in. Option 3 is to use server-side rendering and cache everything that we can. And the last option, so this is the common solution to the single page apps, where we render all its own content. And it's common, but it's often slower than server render apps because it takes time to load the JavaScript before rendering begins. Now let's talk about the combination of progressive web apps with WebAssembly. I found when I was considering modern solution to improve web performance. So they're really modern, but they're for different cases. We use WebAssembly for heavy applications when we need complex computations, where we need enhanced graphics. But progressive apps are rather for smaller apps with static data, with static content. So they are totally different use cases. Because of that, at the beginning, it seemed to be a really abstract solution. And my reaction was like that. But then I found a product that's really applied both WebAssembly and progressive web apps, and I will present you what is it on the next few slides. We know that the JavaScript right now is the only option that is known for writing front-end apps, and we love it because it's really universal. It's so powerful, but we know also that we have some cons, like for example, JavaScript, it's really slow. And we know cases where we will never choose this as solution, like for example, heavy applications with complex computation, because sometimes we just need more than JavaScript offer. And there is a place when you can use WebAssembly, because we can do the same task, but faster. JavaScript is slow. And here you can see the processes of running JavaScript in a browser. So at the beginning, we have parsing. This is the time that it takes to process the source code into something that interpreter can run. Next phase is compiling and optimizing, where we use Bayesian compiler and optimizing compiler. Next phase is re-optimizing. This is another time that we need to optimize code back the baseline code. Next phase is execution, so the time it takes to run the code. And at the end, we need to clean up memory, and we have garbage collector. WebAssembly is faster than JavaScript in many cases. So the first fact is that it's more compact than JavaScript, so fetching takes less time. If we take a look at parsing, so we don't have it in WebAssembly, but we have decoding that takes less time than parsing. In general, WebAssembly is closer to machine code than JavaScript, so the compiling and optimizing process takes less time. WebAssembly has types and other information built in, so it doesn't need re-optimizing. The execution is quicker than for JavaScript. The memory is managed manually, so we don't need garbage collection. Let's talk how you can apply WebAssembly into your web apps. Let's say that we have a module, some parts of our app that we want to write in another programming language, it will be just more effective for our module, for example, in Rust or C++. This code we need to compile into WAS module, and the module will be added to your web app. We will integrate it with JavaScript. The last phase is sending and executing. So we will serve up in a browser that supports WebAssembly, and this browser will execute WASM binaries into a virtual machine. This project combines progressive web apps and WebAssembly. So this is a generator for Rust. Here you can see the official link and link to the repo on GitHub, where you can find the documentation and the full source code. So WAS combines all good things of a progressive web apps and WebAssembly, and it works as a toolchain that allows you to build and deploy mobile app via Rust, and you can easily share your app via hyperlink. And the interaction between WebAssembly and JavaScript is done by WASM-bingen, that this is a Rust library to generate the interrupt codes between WebAssembly and JavaScript. And it's really cool because it allows you to write the entire app in Rust and also use typical progressive web features like PWA manifest or service worker or home screen icons. Now I want to present the results of my experiment, where I try to find the most common performance issue and tips and tricks how to fix it. So I use web.dev platform and measure tool to do performance tests on existing progressive web apps in the production version. So I tested it on 15 progressive web apps. I highly recommend you to try this measure tool from web.dev. It's based on Lighthouse, and it gives you a report regarding your performance of your app, and also it gives you a tips how you can improve it specifically for your web app. And based on this test on the results did on these progressive web apps, I prepared these tips for you how you can improve the performance of your web apps. And the first tip is that we should avoid chaining critical requests. And critical request chain, this is a set of requests that is required for page rendering. And if this chain is longer and the download size is bigger, then your load performance is worse. And here you can see best practices how you can avoid these long chaining requests. And the first tip is that we should minimize the number of critical resources. And there are a few techniques how you can do that. You can just eliminate them, or you can defer the download or make them as async. We should also optimize the number of critical bytes to reduce the download side, the number of round trips. We can also control the order in which these remaining critical resources are loaded, so we should optimize it. And the last one that I think is the most important, we should just optimize images, JavaScript, CSS code, and web fonts. Another really important thing is the number of requests in your web app and also the transfer sizes. So we should keep these requests really low and take care about only small transfer sizes. Another option to improve it is use budget.json file that is offered in Lighthouse. So in this file, you can specify a budget for metrics, performance metrics, and sizes for your web apps. The next step is involved with the browser's render process. The most important to minimize this main thread work is to minify our app, our code, to compress it, and also remove parts that we don't use. Also don't need to send the full app, the full code to our user, but only send the parts that they really need. And to do that, we should apply code splitting techniques. And the last tip is that we can apply caching and use, for example, PRPL pattern. So the abbreviation for this pattern is that we should push, render, pre-cache, and lazy load assets. If we want to improve the loading time of our app, we should also take care about assets and about images. You can lazy load your images and also iframes. And now it's possible to use native lazy loading, but also you have an option to use intersection observer API and to trigger image loads using JavaScript events. If we're talking about images, we should also take care about the size and about the formats. So if we're talking about the size, it should not be too large. If we're talking about proper formats for images, we should use SVG where it's possible. And for example, we should replace complex icons with this format. And now we also have great next generation formats that are better than typical like PNG, that have better compression and quality characteristics compared to the PNG. So if you want to load faster and consume less cellular data, you should encode these images in formats like WebP or other these next generation formats. Now I want to tell you a bit about progressive style. So why we should take care about it. So the CSS is a render blocking resource, and we should take care that this blocking resource is not too large. We should remove unnecessary overhead whenever possible and just optimize it and take care about the proper size and proper selectors in your code. Here you can find the practical tips to keep this progressive style. So first of all, we need to talk about the DOM and the levels that you have inside this DOM. So please remember that changes at one level in the DOM tree can cause changes at every level of the tree. It's really important to minimize CSS rules and of course refactor your code and remove unused CSS rules. If we're talking about animations and complex rendering changes, we should do that out of the flow. And to accomplish this, we should use position absolute and position fixed. The next tip regarding selectors, so we should avoid complex unnecessary selectors because selector matching requires more CPU power. And the next tip regarding additional libraries and foundation that will build your UI, so we should avoid it. And if we don't need it, we can apply Flexbox and Grid, we should use it because it's the same fact that CSS is render blocking resource and every additional framework can delay rendering time significantly. Now it's time for a quick summary. So today I told you about the ways how you can improve the performance of progressive web apps. And I told you about caching. So this is the main source of making progressive web app faster than regular web apps. But please remember that this caching should be reasonable and you should apply proper techniques to cache your network resources. Depends on how does your app is rendered and where does your data live. Please remember about audit tests before caching, about removing unnecessary stuff. Today I also told you about combination of WebAssembly and the combination of progressive web apps. I told you about the project called PWAs. And the last one, please remember that you can achieve better performance if you apply the same performance techniques that are typical for regular web apps. Because if you have heavy app, if you have a lot of assets, external dependencies, and just your app is heavy, Even a service worker and even a caching will not help you. So please remember that you can get fast progressive web app if you have fast web app. So that's all from my side. Thank you so much for watching and have a nice day.